Welcome back, Doug's White here once again, and with the completion of the new house array, I got that all done before winter, and I built that redneck cart, so I was able to use that to pull some PV off of that array. At first I ran 2 strings there, just one to each MPPT. Eventually I came up with the idea, hey, let's parallel a couple strings here, and of course that would clip it here at 5,500 watts on the one MPPT, while the other string was putting out 3,500 watts. So, I was clipping quite a bit of power there. So, put a little more emphasis on let's get some upgrades done here. So that's what this video is about. I'm doing some upgrades here in the house. So let's get started. So these LV6548s I've had in the house here about 3 years, and we've actually run about 30 megawatt hours through them, believe it or not, and they have been trouble free. I haven't had a bit of trouble with them. So it's time for an upgrade, and the main problem I always have with these is I could not use the MPPTs in them because I always ran my string voltage higher than 250 volts. These were the old style LV6548 that were the lower voltage. With the new array being installed, I needed to upgrade. So, and we also had outgrown them. We just needed more inverter capacity. So they're getting replaced, and we're putting in some new inverters, and I'm putting in a pair of SRNE ASPs. So I'm recording this here off a photo, and the reason why is you can see the charge controllers there are lit up, and those fans are really noisy. My furnace would run every now and then, and there's just too much background noise here. In the first part of this video here, there'll be, some narration here. So, but as you can see, I got the inverters off. A lot of the wiring is going to get reused. That was 4 gauge. I'm going to use that actually as a AC input. There were 6 wires, 4 gauge, run through that PVC conduit. That breaker panel is just going to be a pass-through anymore. And there was 6 wires in that conduit, so 3 of the wires are going to go to each inverter for the AC input. I got to add an 1.25 inch conduit coming down alongside that PVC. The trough remains. That's going to be reused, and basically that's it. I don't have to wire up for my battery bank or anything like that. Those all stay. The Class T's will all get reused inside and everything. So, it worked pretty good. I used the redneck cart to power the house while I was doing all this, so it really worked out well. I'm quite happy with how things turned out. So I'll show you here how I assembled the inverters and then got everything installed, and it's been working out really well. So in this photo here, I'm showing the old transfer switch. That was a 3-pole double throw 60 amp, and that's going to be taken out, and in its place is a 200 amp breaker panel. And the reason for that is I needed at least 125 amp panel to backfeed it. The panel above it, that short little panel, that's a 100 amp panel. That's all this house ever had, was 100 amp service. The 2 panels on the left are actually the loads panels, and I'll explain it all later how it's all wired up, and show you how that all works. So I started work here on my house inverters. I have one of my ASPs here on the workbench, and what I've been doing is I'm adding this box here on the bottom. I ordered this box, I hunted around and found one that was about the right height. Basically, I measured it out here, and from my top unit strut that's currently installed, space I'd have in between the trough and the inverter, I'd end up with a space about 3/4 inch in between here, and I'll be able to easily just use a close nipple here to make up the difference. I'll actually put one on each, I think, each hole, probably. So basically the purpose of this box is, part of it is you can only get 6 gauge wire in these terminals. So basically we're coming off those terminals with 6 gauge wire. This side is AC input, this side is AC output. So we're coming off of there. The output's going to feed into this breaker panel, feed this 60 amp breaker. Then I'm going to have 1 gauge wire coming off of these terminals here, and that'll run to a Polaris connector, and the other inverter will run to that Polaris connector, and those will be combined in 1 gauge wire and head back to my panel and backfeed a 125 amp breaker in that panel that'll have a generator interlock. This terminal block here, the purpose behind that is you can only get 6 gauge wire again on the AC input terminals. So I run in here, and I got 6 gauge wire here. My current inverters have 4 gauge wire run to them, and I'm going to reuse that wire in that conduit. So basically I'm just going to run that 4 gauge on into these terminal blocks. Then I'll be able to reduce it down to the 6 gauge and have my AC input. A lot of guys ain't been running AC input in, but I kind of like to do it. That way your battery gets low, you can quick have it switch over. And the wire's already there, the conduit's there. And I was going to have to run the 1 gauge no matter what I did. So, yeah, it's just a square D box, 100 ampere. Going to work good. Basically, I just bored these holes out here to 1 inch and put a chase nipple in there. I got a nut in between it so I can get my cover in between here, you know. And that's it. Pretty simple. It ain't going to take that much. I'm going to have to make 2 holes in the trough to match up with these. But that'll work out really well, I think. So I'll get the other one done, and then I'm going to get started on installing these. As far as the battery ones, I think this is probably going to be 1 inch conduit, because I think my terminal ends are already on my cables, and I think the only way I'm going to get them through is 1 inch conduit. I do have some 3/4 inch flex, but I don't know for sure if it'll fit through that. This here is going to be either FMC or it will be 3/4 inch conduit most likely, and I'll use a 1 inch to 3/4 inch washer to fill in the gap here. I don't know why they make that hole oblong, but that's what I'm going to do with that. So that pretty well covers it, you know. That's basically how it's going to be wired in. You know, that makes it pretty simple because we'll have a 60 amp breaker here. The other one will have a 60 amp breaker. If I decide to add another inverter down the road, I can just add that inverter with its own breaker box and also tee that into the line too, see? So anyway, I'll get started on this and get the other one done, and we'll get moving on. So as you can see, I have a pair of SRNE inverters replacing the LV6548s, and let's go in for a closer look. As I showed you before, I was assembling it here in the shop. I got my bus bar here, and that's my AC input in. These 4 gauge wires were here from the old inverters, and I just reused them and made them the AC input. This is 1 gauge, and I can tell you right now, this is a 60 amp breaker. And the only way I got that wire in is I'd take 2 strands off. The only other choice I would have had would have been jumping back down to 4 gauge. And it comes down here and it wraps over and goes to these Polaris connectors to join up. And I could have ran 4 gauge there, but I really didn't like that idea. And then it joins over and back feeds a 125 amp breaker in the box. But yeah, the neutral wasn't an issue. It's the breaker, you know, and I don't know if Square D makes a breaker with a bigger terminal in it, but I do know probably the brand I use in the shop, which I don't even remember what it was. Those I think had a bigger terminal in them, and I think the 1 gauge would have fit right in those. But yeah, it was one of them things I ran into, and I was like, well, I guess I'm taking 2 strands out and making it work. Part of the idea was if I ever had to replace these inverters and something bigger, then this is a 100 amp box, so I can pop that breaker out and put a bigger breaker in it. But you know, these inverters require a 63 amp breaker. One of the closest you're going to get is a 60 amp. So attach it here. I just use, you know, a couple of nipples and had to punch those holes. But most of the holes I was able to reuse in my trough. Had to use a block off there. These holes were reused. The only one I had to use an offset for the conduit basically was this middle one for my battery cable. These other ones, you know, kind of lined up. Same thing over on this one, you know. So that worked out pretty good. I'd kind of done a lot of measuring and kind of figured it out. So, you know, you can see what it looks like with the cover on it. This one here was my PV, and actually that hole was there, and it just runs on over, and my AMOs are over there. See? So, yeah, it worked out pretty good. I didn't have to move that unistrut, but I did have to take this bottom one loose and move it down slightly. Like I said, I'd done a lot of measuring, and I knew that this box was just the right height to fit in there. You know, and I got into it, and I thought, well, you know, it's tight in between here, a little tighter than I'd like it, but I'm limited on the space. You know, I have my IMO here, and I'm limited over here on this side. So this breaker panel here was already here from before. That was 60 amp breaker was for my AC output on my old inverters, and so I reused it. I just left the breaker in there, but now I'm feeding power from the other direction. That's my AC input in. This 1.25 inch conduit that runs up here now is my AC output. Runs over to my breaker panel. I had 6 wires in this conduit, so I was able to feed both inverters with 4 gauge coming on over here, and I got a 60 amp breaker in the panel, grid panel over there, and so that all worked out good. So I didn't have to do much changing in the box. The only thing I did was, of course, tighten my 4 gauge up to the top. My PV comes in there and just routes up there, and the other one runs over there. I'm only running 3 strings. I didn't have to change anything. The only thing I do is shorten up my battery cables here slightly. And those all stayed. And then I took my Polaris actually and turned them vertical, if you hadn't noticed. That worked out really well because then I was able to come past it here. So that worked out good. Run my 1.25 inch conduit on in here and got those wires in. So everything worked out really well. I'm really happy with how it turned out. So I'm getting ready here to put my covers back on. And I'll be glad when this is all done. I got a lot of cleaning to do, so just the way it goes. So before I hooked it all up here, I had taken the cable loose off my Class T, and I had an extra 48 volt forklift bulb and a pigtail. And being I was using the system, powering my house up with the redneck cart, I couldn't just use my pre-charge resistor that's already on my battery bank. So basically I would use this light bulb setup to pre-charge each inverter. That worked out really well, you know. And as far as my ground, I got a bonded bus bar here in the back, and then any of my miscellaneous grounds I have, I just run here. But as far as the AC input here, that actually runs all the way from the main box. So anyway, I'll go show you my panels over there, my electrical panels, and how that's all wired, and I'm going to get these covers all on. Like I said, I got a lot of cleaning to do here. I got a lot of wire to get rid of and clean up, and Lord knows what I'm doing with all that 4 gauge, but I don't know. Some of it I used and some of it I didn't, but that's the way it is. So over here on my panels on this house here, I had to build just a stub wall out away from the wall because my heat runs run behind it. But we'll start here. This is my grid panel. It's a 100 amp panel. That's all this house ever had was a 100 amp service. So grid power comes in to this main breaker. And I'm short a 100 amp breaker here. And that's to feed power down to this panel, to these 2 terminals right here. Okay. And I did run the neutral already because I needed to get it bonded here to my neutral ground bond at my pole. But I got another 100 amp breaker coming, but these 260s in here are for my AC input to my inverters, and of course they're off, and the only time they'll ever be on is when I need it. So of course the 1.25 inch conduit come down here, and it runs down here and back feeds this 125 amp breaker. I have a generator interlock here on the cover, so this breaker can't be on when this one's on, and vice versa, of course. This 100 amp breaker here feeds this panel up here on the top left. That's another 100 amp panel, and as I started adding heat pumps and everything else, I added this bottom panel because I was starting to run out of space. So this 100 amp panel actually is going to be fed out of this panel here eventually. So, but you know, it's pretty simple. I had the transfer switch in here, and that was 60 amp, and of course it wasn't big enough. And being these inverters put out, 60 amps a piece, 63 amps they're rated for. I couldn't feed it into here anyway. Plus I wanted a grid feed, so I said, well, and I had the wire there, of course. See, I didn't have to run it, so it didn't cost me anything there. So I said, well, that's no problem. I'll just add a 200 amp panel down below it. Put my generator interlock in there, and yeah, I don't need all that space, but it was cheap enough to come with the 200 amp breaker, and that's way if the next person ever decides they don't want solar, they can take this top panel out, run their grid feed right on in there. They'll have a 200 amp feed if they change the wire coming on into the house. So, it'll be all set up for it, and then these 2 panels here will feed off of it. So, it's been a lot of work, but and this is going to be the final upgrade on this deal. I'm done, I don't see ever doing it. The other reason, if you ever went to a hybrid inverter or something like that, this 200 amp panel would allow you to backfeed into it, But you'd have to change out your service, of course, you know, and then tear this panel out and run new wire over the pole. But I did have to add a jumper wire in between here and here because I had the grid disconnected to this panel up here. When I pulled the transfer switch out and I put this panel in, I still had the LV6548s in, and I couldn't run with the grid connected with the double bond, see, because the inverters bond neutral and ground. So I disconnected the grid while everyone gave it a thought, and then I put the redneck card on and got up in the morning, and it was real cold in the house, and I thought, what the hell's going on? You know, the furnace wasn't running, and I went down here and checked the code on the furnace, and it said improper grounding. Well, yeah, well, there wasn't any neutral ground bond anywhere. So I tried setting the inverter for it, but that didn't work. So I ended up putting in a jumper wire in between the grounding bus bar here and the neutral, and then it was able to run. So if you're running an SRNE ASP and like your furnace don't run or whatever, just ground it here in the bar, or you know, have your neutral ground bond back at your pole. But anyway, that's how this has all been, you know, since I've been here. You know, I had this panel here, and then I had a breaker there that fed down the transfer panel. And then I had another breaker there that fed power over to my LV6548s. So basically, you know, I just took out the transfer panel and added this 200 amp panel here where the generator interlock's got to go in there. So basically that's it. You know, it's pretty simple. And that's the way I like doing it. I did the same thing at the shop. You just have a grid panel where you have grid power coming in. That allows you to feed grid power from here down to there, and you can also feed your inverters. Okay. So I'll get the cover on here, and then I'll show you here how it all works. So my 100 amp breaker came in, and we're here at the top panel. Of course, these two 60s here are my grid feed for my inverters. This 100 amp breaker here is wired into the panel below it here, and it's wired into the main breaker here. I have my generator interlock here, and I have my backfed breaker here, and a hold down kit on this backfed breaker. All right, that way nobody can remove it. That way nobody gets shocked. So, of course, the purpose of any interlock, generator interlock, is you can't have both power sources on at the same time. You can't switch this breaker on when that's there. When you switch this over, then this plate will drop down, and you can switch your other breaker on. And that way, when this breaker's on, you can't switch this one on. All right. So this is my 125 amp breaker here. This is backfed from both of my inverters. Feeds the bus bar in here, and then this 100 amp breaker here feeds the top left panel over there, and then this 90 feeds the one right alongside of here. So those are both my loads panels. Okay, so that's how that all works. So if I wanted to switch to grid power right now, basically I would shut this breaker off. This plate would drop down, and I could switch that on there. The other choice is I would switch to utility in my inverters, and I'd have to have both these breakers on. I'd have utility first, and then it would power through the inverters on utility. So this way I got it covered both ways. You know, if my battery got low and I wanted to switch to grid power, I can do it that way. Or if I wanted to bypass the inverters entirely, I have the option of going through this breaker and shutting this one off and powering everything. So okay, that's how that all works. It's simple, it's easy, and it's not that high price. So, you know, it's better than putting in a transfer switch. And your bonding's all done for you. My bonding here is done at my pole. So, you know, if you didn't have a pole like that, you would bond in this panel up here, which would be your grid panel, your first means of disconnect. Okay. All right. I'm going to show you here on Solar Assistant what I had to do there. So when I did Solar Assistant here, originally I ran a pair of USB Type B cables here, and you hook it into the USB Type B port, which is right over here. And I would notice that sometimes on inverter 1, it would lose the connection. The second thing I would notice is on inverter load, on one phase, the load would be half of what it would be on inverter 2. And then the second thing I noticed is sometimes inverter 2 would then become inverter 1. And I could tell because I only have one PV string on inverter 2. So I talked to Boric. I had figured out that it was the connection at the USB port, the Type B port on the inverter on the board. And I bought these from Boric, which is the distributor for SRNE on Alabama. And they came back, and of course they had this excuse, that excuse. But I told them, I said, no, it's in the connection. And I said, really, I need a new board. And they came back and said, yeah, SRNE would give me a new board, but I had to pay a small shipping fee. Well, they came back and said, well, it was going to be $60. They had to air freight it in because it's the size and this and that, and they want to know if that was acceptable. And I said, no, I'm not paying $60 for something that should have been covered under warranty. And I left it at that, So, meanwhile, there is the U.S. distributor that started for SRNE here in the U.S., and they are a member of the Do-It-Yourself Solar Forum, and I got in contact with them. And they are currently working on the process of being able to, they're in negotiations and the ability to warranty all SRNE products, whether they sold or not, that are here in the U.S. So in the meantime, I decided to use the RS-485 connection. And what I got is I have a pair of WaveShare RS-485 to USB converters. And then that'll allow me to plug those into my Solar Assistant. And I just got that done today, and that's been working just fine. I had messed around with the USB Type B connector and moved it around in there. And, and I actually had gotten to the point where it was pretty stable. But actually, I think in the shop, I'm going to switch that over to using the WaveShare because I've noticed that the PV will be less than what the load and what's going in my battery. And I said, well, obviously I have corrupted data here somewhere, so that I think is going to happen there too. So, but this has worked out really well. You're able to plug one WaveShare directly in, and being I have my shunt cable for my Victron shunt, I had to use the USB cable they supplied, but I didn't have any trouble with that. So some say to use an isolated converter, but and the WaveShare is recommended by Solar Assistant. So I went ahead and Solar Assistant recommended using this style, so that's the ones I went. And they had a deal on Amazon where you could buy a pair of them for $24, and I said, you know what, that's just the way I'm going to go. It's obviously it's supported by Solar Assistant. Anything else really wasn't, unless you buy the other cables that they recommend on their site. So, I figured I'll just go that route, and that way if I had any problems, I could just contact Solar Assistant support, and that would be just fine. And they recommended in a private email, their support is really good. They responded within 24 hours and said, yep, that would be a good idea to try the RS-485. So that's what I'm going to do in the shop. I'm going to go ahead and change that over too. So anyway, that fixed that problem. I'm not going to spend the $60, and I highly recommend using the RS-485. I know there was a problem back in the days of the EG4, and people would be using the USB Type B port for communication, and they ended up using the RS-485. So just a word of advice, use the RS-485 if you can. I think you'll have a lot less problems. Yeah, as you can see, it was a pretty easy upgrade. Didn't take much. I started there over the Christmas holidays. It took me about 4 days or 5 days. Around the 29th, I got it done. We're now deep into January. I think today's the 24th or something like that. And I've run just about 1 megawatt hour through those inverters already. It's been cold here, and I've been heating my house entirely off electric during the day. Pretty amazing, between the two arrays. With the wind damage to the recent array, I'll get all new panels on that, and I'll even have more power to use up. So I've been generating around 140 kilowatt hours a day running through those inverters and the other two charge controllers. It's worked out really well. I'm very happy with how things have turned out. It was a very good upgrade. Now SRNE has come out with the AVP series, and those have the breakers built in the bottom. They're offering those in about a 12 kilowatt to 16 kilowatt output. They may work for you, but they're going to be more costly. I had bought I had bought three inverters before the tariffs went in, and I paid $2,800 for those shipped to my door direct from China. But I did have those problems with the communication board, and then I had to deal with Boric. There is a U.S. distributor now in the United States. I do highly recommend probably buying from them. It might cost you a little bit more, but if you need support or warranty, it's probably worth it. You know, do I think you're going to need support or warranty? Yeah, maybe, maybe not. But still, it might be worth that for some people. So, you know, I've been pretty satisfied. I mean, I'm really taxing these. I've taxed them as heavy as over 11 kilowatt output already, and doesn't phase them a bit. You know, it really has worked out well. I don't have to worry so much about load management. My wife can run the washer, dryer, whatever, and we don't have to worry about an overload situation. So, very good upgrade. Very impressed. And this will be the highest month in the past 12 months for usage. So we'll just keep continuing to just keep adding more and using it up. And the goal here is eventually that we're going to use as much excess PV as we can to heat our house. And those upgrades will be coming in future videos. So if you like what you see here, hit the like and subscribe button. I got more content coming. And as always, catch some rays, and we'll see you later.